Hey everybody, welcome back. So in this series of tutorial, we are covering why string is immutable in Java. So in the last video, we have covered that what we understand about an immutable class, and also we have covered why string is immutable in string pool point of view. But as I said you before, there are different reasons why this string class is designed as an immutable class. So today we're going to explore another reason, and the reason is the string used as a key in the hash map pretty much. So if you look into your real-time application, you can find that you are using string as a key pretty much in a hash map, right? So string is a very good candidate as a key in the hash map. So why is that? What is the reason behind it? So to make you understand this, I'm going to talk about this particular topic, string hash code caching. So whenever you compute the hash code for your string, it's been cached in your string object forever, right? So the hash code for the string has been computed for only one time, then getting cached inside your string object. So what I mean by that, okay, and how JVM is doing all these things, and what is the string hash code method is all about. We're going to talk about it, everything practically. We're going to debug it. We're going to see this thing internally in this particular tutorial, all right? So a lot of good things in the store. So let's go ahead and explore it, but right after this intro. Alright, so before we move into Eclipse, let's have some basic understanding about this hash code caching. Alright, so the string hash code is only calculated for only one time in your application, right? So what I mean by that? So let's talk about if you have a string s equal to a v. So let's say this is a string. So in your memory, there is an object, and this s is referencing to this particular object, right? So whenever I'm asking to calculate the hash code for this particular object, what is going to happen here? JVM is going to use all these characters to calculate the hash code. So internally, JVM is going to take A, B, and I. It is going to loop over all these characters, and it is going to calculate the final hash code here. Let's say 111, 2211. For an example, right? Your hash code will be an integer, right? So once JVM calculates the hash code, this hash code is going to be cached into your object. So inside your object, this hash code is going to be stored 12211. Let's say it's going to be cached inside your string object. So further in my application, if there is a need of calculating the hash code again, JVM is not going to calculate it. Instead, it is going to use this particular hash code which has been already calculated. Why? Because string is immutable, right? If string is immutable, this content will not be changed, right? So JVM is using the content over here to calculating the hash code, right? JVM is looping over all the characters of the string and calculating the hash code. So this is a time-consuming process, right? Think about a large string. Think about a string with 100 characters. Like think about an address, right? Having country name, district name, state name, zip code, and all. So this is going to be a large string, right? If we need to calculate the hash code, we need to loop over each of the character in the string. Then only we can calculating the hash code over here. So there is no point. This doesn't make sense to calculate the hash code again and again because string is immutable. This content is not going to be changed. So we calculate the hash code for only one time and then caching it inside the string object. So internally, string is using a variable called hash to store, the hash code, right? We're going to see everything practically right now. So let's go to Eclipse and let's debug the things and let's see how the string hash code method is working in real time. All right, so let's go for it.
All right, guys. So now let's understand how the string caching works. Okay, how string caches his hash code and what is happening internally and what code has been written inside your string hash code method and how the things are happening behind the scene. All right. So to make you understand this, I've created a simple class here called string hash code testing, and I have a main method. Okay. So right now let me go ahead and let me type one or two line of code. String str equal to, let's say, hello. So this hello is a string, and I'm going to do str.hashcode. So this piece of line is going to calculate the hash code. Alright, so right now if I want to see the internal implementation, I need to debug this application, and so I'm putting a breakpoint over here, and I'm just doing a right click, debug as Java application, and I do have some error in my project, so that's not a problem. Well, there you go. So there's your full debug screen, but to view that I'm gonna minimize it. Okay, so right now I can see my full debug screen over here. Okay, no worries. So right now what I'm gonna do, I'm gonna do a step over. Okay, so I'm in my line number 7, so I'm going to hit F6, or this one in the screen right over here. I'm gonna hit this step over, and here we can see a string object has been created, and it has the hash, which is 0. And if you talk about the value is hello, right? And this is how your string is storing your content, hello, right? So as you know, your string is backed by an char array, or whenever you store something as a string object, the string uses the character array to represent the each characters here. So internally string uses an char array to store your elements, right? So HELLO, the array indexes starts from 0 and it goes up to 4, because this hello has the length of 5. Okay, so 0 to 4 is a 5 length. Alright, so that's about our value, but the one that we have interested over here is this hash. So this hash is 0 because right now whenever we create a string object, the hash is not computed. Whenever we request for the hash code, at that time only it is going to get computed. So right now whenever the string object is getting created, the hash is 0, as you can see over here. So right now I want to execute this line of code, str.hashcode. So right now let's execute this line, or let's go into this particular method hashcode, what it is doing and how it is computing a hash code. Let's observe that. Alright, so I'll do a step into, because I want to go into this hashcode method. So as you can see right now I am inside my hashcode method. So let me zoom it a bit so that we can see it properly. Alright, okay, so right now we are in our hashcode method. So so this is what the developer, the Sun Microsystem people has been written. This is our source code, and this is our hashcode method for our string. Okay, so the first thing that you can see over here, int h equal to hash. So this line is actually working as a cache, okay, or you can say this line is actually cache the hash code. Okay, so how we are going to explore it in a bit. So first thing that I want to get acquainted with, so you can see this one, this hash variable. Okay, so this hash is a variable. So initially you can see the value of hash is 0 because it's not get initialized already. So right now if I open the declaration over here, so we can see our string class is here, our string class is public and final, and inside your string class we have a variable, and the variable name is hash. Okay, and the default value of this hash is 0, and this hash is used to cache the hash code. Okay, cache the hash code for the string. So you can see the comment over here. All right, okay, so now let's understand how this variable hash works. Okay, and how is cache the hash code. Okay, so so to make you understand this, so let's go back to our hash code method. Alright, so here we go. Okay, so let's forget about this for a moment. Okay, we are going to get back to this particular point. So right now this particular variable h is initialized to hash. The value of hash is 0 initially. So right now there is a kind of if clause is over here. Okay, so we can see over here there is a if clause. If you see over here, this h is equal to 0, this condition satisfied because this hash value is 0 already, and the length of the value should be greater than 0. So if you talk about the value right now, our value is hello, right? So we can see it over here, our value is hello, and this has been stored inside a char array. So right now this particular condition matches. The value of h is 0 because this hash is 0, and the value length is greater than 0 because our value is hello and its length is greater than 0. So right now let me do a step over. So it comes to this line, I'll do a step over, it will go into the loop because the condition satisfies, and now there is a for loop over here again. So this work of this for loop is actually, it is going to calculate the hash code, and how the hash code is getting calculated, and that's being calculated by looping over each character of your string and calculating the hash code of it. Okay, so as you can see over here, this value of this I is 0, because if you talk about this char array, uh, the first index of the char array is 0, so it's going to iterate over each element starting from the 0th index till the last index. All right, so if I'll do a step over, you can see this is going to calculate the hash code for each character, and once it is done with that, it is going to store this h, okay, whatever is calculated over here, it is going to store that with this hash variable. Okay, so we have seen that this hash is actually our variable which is inside the string class, and this hash variable is used for caching. Okay, so we're going to see that in a bit. Okay, so let me minimize it once again, and let me go back to the hashcode method. Alright, so there we go. Alright, so if I'll do a step over right now, so you can see our hash has been calculated, and my hash value is 99162322 something. This is just an integer. Alright, and right now this h is going to return me the hash code, okay, because our hash code is returning an integer, right? So we're going to return this h over here. But before that, whatever the hash code is getting calculated over here, we are setting this hash code to the variable over here hash. Okay? So now the hash has been set to this particular value, and the value of hash is changed to this value from 0. All right, so right now if I'll do a step over here, I'm going to get back the hash code. Okay, so my str hash code right now, instead of 0, I'm getting this particular value over here, and if I'll open this, I can see the hash code has been calculated, right? But the thing is, right now whenever we demand the hash code for our string, it's been calculated and cached in the memory. It's been cached inside the string object. So from now on, if any point of time we need the hash code calculation again, it is not going to calculate it once again. It's just simply going to use the cache, which is the hash variable in this case. It's just going to get the value from that particular variable. All right, it is not going to calculate it once again. It is not going to calculate it a number of times, because this is a time consuming process. Because if think about a large string, for a large string, the for loop execution will be done for a number of times, right? So that's gonna consume a lot of time, and for performance wise, this is really bad. So once the string hash code has been computed, it's going to be cached in the memory. Okay, so to prove this, I'm gonna take this hash code method few times more, and let's see what is going to happen internally. All right, so right now if I save it, Eclipse is just saying me to restart it, so I'll do a restart, and let's see what is going to happen over here. Okay, so right now let's rerun this program once again. So if I'll do a step over, my string object is getting created, the hash is 0. So if I'll right now I'm over here, first time I need to calculate the hash code. So if I'll do a step into, you can see first of all this hash is 0, and right now if I'll do a step over, the condition matches. Our string is hello, as I said you already, the value is hello. So the value is so the value length is greater than 0, and the hash is equal to 0, because initially the value of hash is 0. If I'll do a step over, it goes into the loop, it's calculate the hash code by looping over each character, as you can see over here, and now it set the hash code to this particular hash variable. Okay, so if I'll do a step over, I can see this, the hash variable has been set. So if I'll do a step over again, it's going to return me the hash code. As you can see, the hash code I found over here. Now the next thing, if I'll do a step over again, and right now I want to again calculate the hash code of the string. But remember, the string hash code we have already computed over here. We have already calculated over here in this line. So the string caches it. So we don't need to compute it once again. So if I'll do a step into, I'll go into the hashcode method again, but this particular loop is not going to be executed because this h value is not 0 right now. If I see over here, this hash has been already computed and this particular value has been set to this particular integer h, okay, to this int value h. So the loop is not going to be performed again. So instead, if I'll do a step over again, it's just going to avoid the loop and come directly to our return statement, and it is just going to return me this particular h. And just a reminder, this h is already hold the value of the hash, right? So this hash is actually, as I have already shown you, this is actually this particular variable, and right now the value of hash has already been set to this particular value, not to 0, because the 0 value has already been overridden last time, right? So let me go back. Alright, so I'm here in my hashcode method. So if I'll do a step over, so you can see my str, I got the hashcode for it. It's not get computed once again, it's just returning me the cached value. So if I to view that again, here again I'm calculating the hashcode. So if I'll do a step over here, and if I'll go into this particular method, again the hash value is already been computed and already been stored. The hash value is not 0 right now because it's already been computed. So this particular loop is not going to be executed once again. So if I'll do a step over, is just going to avoid this loop and directly come to the return statement. And if I'll do a step over here again, I got my hashcode. So the point to prove here is the hashcode is not getting computed again and again, as is a time consuming process, because looping over the each character of the string and calculating the hashcode is a time consuming process. So to avoid this, we're using string caching, because we know the string is immutable and the content is not going to change. So what we are doing over here, once the value has been computed, the state of the object is not going to be changed. So we are caching it into our string object. So in the next time, whenever we are requesting our string for the hashcode computation, so at that time what is happening is just giving me back the hashcode which has been already computed and already been cached inside the string object. So that's the thing that you need to remember. Right now, let's go ahead.
Alright, so right now we have the kind of understanding what we mean by string hashcode caching. Okay, so we understood that string is immutable, that's why we are not calculating the hashcode for the string again and again. But how this is helpful? Alright, think about your hash-based collections. Think about your hash map, where we are using string as a key. So here I have created a simple hash map by taking string as a key and integer as a value, right? My reference is hm, and I have used new hash map, right, to create my hash map object. So now think like, if I'm trying to put any object to my map right now, if I'm doing hm.put, if I do a put operation, let's say AA and 1, my key value pair. If I'm trying to do any put operation right now, even if I'm trying to do any get operation right now over this map object hm, this hash code is going to be calculated. The hash code for the key is going to be calculated, right? So in your hash map, whenever you're doing put or get operation, frequently you are calculating the hash code, right? So I have covered it in my internal implementation of hash map video, right? If you haven't watched it yet, you can find the link down below in the description. But the point over here is, each time we are putting an element, or if we are getting an element, we are calculating the hash code, right? So think about in your map, internally it uses, internally is create an array of buckets to store elements, right? So whenever we are performing a put operation, where this key is going to be stored in this bucket, to find out this put operation internally going to calculate the hash code of this particular key, and this is going to place this key value pair in a certain bucket, right? It's going to place it over here. The key, the value, the key is AAA, and the value is 1, and some other information is also going to be stored inside your bucket, right? So to find out in which bucket this particular key is going to be stored, the hash code needs to be computed, right? Similarly, whenever we are doing hm.get of AA, right? If I want to have a get operation, then also to find out in which bucket this AA key is in, to find out that, again, the hash code needs to be computed for the key AA. Alright? So think like if I'm doing 50 get operation here, 50 times the hash code need to be computed, right? So if I do 50 get operation, 50 times the hash code need to be computed for the key, right? But wait, here in this case, this is not going to happen. Why? Because we're using string as a key. And for string, the hashcode need to be computed only one time. Let's say here in this case, during put operation, for the key AA, the hashcode is getting computed, and once it's get computed, it is going to be cached inside the string object. Let's say inside the AA object. So AA is a string object, right? So once it's get cached, even if I'm doing 50 get operation, during this get operation, when this get method is going to look for the hash code for this key AA is already get computed. So it's just going to retrieve that particular hash code which has already been cached inside the string object, right? So there is no further computation of the hash code need to be done for this particular get operation. So this is just saving us a lot of time, and this is also making the things really fast, right? So this is why we're using string as a key in the hash map, because string caches the hash code, and this is really beneficial for faster retrieval or for faster insertion kind of thing.
Alright guys, so let me sum up everything pretty quickly within a minute. So you can see I have a class over here called string hashcode tasting, and I'm going to create another class over here called my let's say my demo. And here in this class, I'm gonna override the hashcode method. So there we go, our hashcode method has been overridden here, and I'm just going to have a print statement over here because I'm just going to track it. So I'm going to say hashcode method called, right? Just want to make you feel that this hashcode method is getting computed every time you are performing a put or a get operation. Alright, so right now let's come back to this particular class, string hashcode tasting, and here in this main method, I'm going to have a hash map, and I'm going to take my demo as a key. So my demo is my user-defined class, and the value I'm going to take integer. I'm going to give it a reference hm equal to new hash map. Now I'm going to create a my demo object, and I'm going to have a put operation here, hm.put, and I'm going to put this m over here. This m is the my demo object, right? And the value I'm going to give a random value 1. And if right now I'm going to run this application, you can see the hashcode method get called, right? Because during the put operation, internally this put method is calling the hashcode method of the key. Right here, my key is my demo m, right? This belongs to the my demo class. So the hashcode method of my demo class is getting called. So right now, let's say I'm going to have a get operation, and I'm going to look for the key m, and you can see my hashcode method is going to be called 2 times, one for the key, one for one for the put operation, and one for the get operation. So if I'll do it for a few more times, so as many times as I'll do the get operation, the hashcode method is going to be get called. So here it is confirmed, my put method and get method is calling the hashcode method again and again because they want to compute the hashcode before inserting an element to the map, or when they want to look up for a key inside the map, right? During the put operation and get operation, right? But here is the thing that you need to notice. I'm here using my demo object as a key, right? And this particular class is a mutable class, right? So if you debug it, each time it is going to go into the hashcode method and is going to be compute the hashcode, right? So it's going to take so much time, right? But if I'm going to use the string as a key over here, right, then what's going to be happen here, and if I'm going to insert string key, string object over here, let's say if I'm going to insert hm.put, and I'm going to insert a string and value here, let's say 1, right? I don't need this. So here in this case, if I'm going to have a get operation, I'm going to look up for the key AA. So in this case, also the hashcode method will be get called, but the thing is, here the hashcode calculation will be done only for one time, right? So string kind of works faster in compared to the other class that we have created over here, my demo, right? Because this is mutable and string is immutable. So that's it.
Alright, so this is it for this tutorial. In the next tutorial, we are going to explore some more reason why string is immutable in Java. So if you like this tutorial, just give me a like. If you don't like this tutorial, feel free to give some suggestion to me. And I'll see you in the next video. If you have any query, you can post a comment or you can write a mail to me at seleniumexpress@gmail.com. So I'll see you in the next video. Till then, bye-bye and happy coding.